Good morning. Welcome to CEI. This is Dr. Sekhar Chandra, chemistry teacher. I'll teach today water, though I have started the last class. Uh, Properties, chemical properties of water started. Now there are few questions arising in this chapter. I've written these questions, specially explain why or give reasons. These are 5 or 6, 7 questions are there. One by one I'll discuss today. Okay. Previous class, chemical properties I have completed. So, related questions in what the chapter of water, I'll discuss one by one the questions I have written on the board. So the first question is the dissolved air in water contains higher percentage of oxygen than ordinary air. Now, you know that air contains various gases, mainly it contains nitrogen and oxygen. Okay, though there are few gases are present like carbon dioxide, inert gases, water vapor, etc. But mainly we know that air contains air contains nitrogen and oxygen. And we know that since oxygen is more soluble in water than nitrogen, so we get dissolved air in water contains higher percentage of oxygen than nitrogen. I repeat, in air, the main constituents are nitrogen and oxygen. Nitrogen is less soluble than oxygen, so oxygen is more soluble in water. So we get in water higher percentage of oxygen than nitrogen. Okay, the first question I have discussed. Second question, biological importance of dissolved air in water. Now, what is the importance of dissolved air in water? Now we know that dissolved air contains oxygen and small amount of nitrogen, but mainly dissolved air contains oxygen, and this oxygen helps the living organism to survive for the respiration. So living organisms means aquatic animals, aquatic plants, etc. They survive because of the dissolved air, because dissolved air contains dissolved oxygen. Secondly, aquatic plants, they undergo photosynthesis with the help of dissolved air or dissolved oxygen. So there's the two main importance, that is biological importance of dissolved air in water. Number one, that is respiration for the living organism, for both aquatic animals and plants. And secondly, for this they survive. And secondly, the dissolved air helps photosynthesis for the aquatic plants. So we discussed biological importance of dissolved air in water. Third question is biological importance of dissolved minerals in water. What is the biological importance of dissolved minerals in water? We know that water contains many minerals which are in the form of soluble form. They are present. That means solution of the minerals. Solutions of many salts are present in water, like magnesium chloride, calcium chloride, magnesium, etc. There are other also minerals are present other than calcium and magnesium. So, what are the importance of those soluble minerals in water? The main importance is they give some refreshing taste for water, because we know that distilled water or the water having no minerals have a flat taste, but when it contains the dissolved minerals, it has a refreshing taste. So we get taste in water because of the presence of soluble minerals. Secondly, the minerals helps essential minerals helps for the living organism for their growth, for their survive, etc. So dissolved minerals are very important for the living organism. And third biological importance of the dissolved minerals in water is it contains carbon dioxide. This carbon dioxide reacts with the minerals like calcium carbonate, there is marble stone or dolomite, magnesium carbonate, to form soluble calcium and magnesium bicarbonate. And this calcium and magnesium bicarbonate helps to form the cells for the aquatic animals like snail, turtle or tortoise, etc. They form their shell to protect themselves due to the formation of calcium and magnesium carbonate. So there are three important importance of the dissolved minerals in water. I repeat, number one, refreshing taste for the dissolved minerals. Secondly, dissolved minerals helps uh, for the living organism, for their growth, for the survival. And third, some aquatic animals like turtle, snail, tortoise, etc., they form their body covering. They form their body covering to protect themselves from the enemies with the help of dissolved carbon dioxide, which forms bicarbonic acid, and they combine with the carbonates of calcium and magnesium to form calcium magnesium bicarbonate, which help to form the shells for the aquatic animals. So we discussed 1, 2, 3. The fourth, water is an universal solvent. Why it is a universal solvent? Because water dissolves most of the inorganic salts, many organic compounds. So we can say that it is an universal solvent because almost all kinds of chemicals it can dissolve. So it is an universal solvent. Now fifth one, water is polar but carbon dioxide is non-polar. Now water is polar but carbon dioxide is non-polar. How will I explain? Now to explain, that is water, first of all the structure. What is the structure of water? Water structure is, this is the structure of water. It is an angular structure and they form covalent bonds. Hydrogen with oxygen, this hydrogen with oxygen, they form the covalent bonds. Alright, carbon dioxide structure, central atom is carbon and there are two oxygen atoms, they form chemical bond that is called double covalent bond. Single covalent bond in case of water, double covalent bond in case of carbon dioxide. Now it is an angular structure, it is a linear structure. Alright, the central atom is oxygen, the central atom is carbon. So let me conclude regarding the structure of both the molecule. Water is an angular structure and carbon dioxide is a linear structure. Now how does the structure affect on the polarity of the molecule? Now you see that oxygen is more electronegative than hydrogen. Oxygen is more electronegative than hydrogen. What does it indicate? It indicates it attracts the bonding electron. It attracts the bonding electron towards its nucleus. Since oxygen is more electronegative than hydrogen, so the bonding electrons which are present in oxygen and hydrogen will be attracted by oxygen towards its nucleus. Similarly, here also we find, in this case, the same phenomena will happen because oxygen, due to its more electronegativity, attracts bonding electrons towards nucleus. So hydrogen becomes slightly positive charge and oxygen will be slightly negative charge. This will be slightly positive charge and this will be slightly negative charge. But the resultant dipole moment will shift towards upward direction. Resultant dipole moment means resultant force of attraction will move towards upward direction, which makes the molecule polar. So it is a polar molecule, or it is a dipole, or it has a dipole moment. So I repeat, due to its angular structure, oxygen will attract bonding electrons from both the hydrogen towards its own nucleus, for which it becomes slightly negative charge and both of them slightly positive charge, and as a result, the resultant dipole moment will shift towards upward direction, making the molecule is a polar. So water is a polar. On the other hand, what we will find in carbon dioxide? In carbon dioxide we will find it is a linear structure, and we know oxygen is more electronegative. Oxygen is more electronegative than carbon. So carbon will be slightly positive charge, oxygen will be slightly negative charge. What does it happen for that? Due to its more electronegativity oxygen than carbon, it will attract the bonding electron towards its nucleus. So it will be towards oxygen. Similarly, here also we find the same phenomena because oxygen is present, which is more electronegative than carbon, so it will bonding electrons will be shifted or it will attract the bonding electron towards its nucleus. And since the molecule is linear, the resultant dipole moment will be 0. The resultant dipole moment will be 0, so the molecule is non-polar or it has no dipole moment or it is not dipole because of its linear structure. Because we know when we attract anything in the same way, in opposite direction with the same force, the particle does not shift. So the resultant force of attraction will be neutralized due to the same force in the opposite direction. So you can conclude that carbon dioxide is a non-polar because of its structure, linear structure, and due to its linear structure, the resultant dipole moment does not shift, making it the molecule is non-polar. So we discussed about the water is polar and carbon dioxide is non-polar. I hope it is understood by everybody. Now, next question was, water is liquid but hydrogen sulfide is gas. Water is liquid but hydrogen sulfide is gas. Now, water being its angular structure, I told the previous question, and oxygen is more electronegative than hydrogen, bonding electron will be shifted, making the molecule is polar. There will be slightly negative charge, slightly positive charge. This part I have already discussed the previous question. Water, though I repeat that oxygen being its angular structure, bonding electron will be shifted towards the oxygen atom, making oxygen atom negative charge, and hydrogen will be the slightly positive charge. In case of H2S, if you find the structure, the same structure, angular structure, here also we find it will be slightly negative charge, it will be slightly positive charge, this is slightly positive charge. Why? Because hydrogen is less electronegative than sulfur. Since sulfur is more electronegative, the bonding electron will be shifted towards sulfur in both the cases, and they're making this atom slightly negative charge, this one. But since we know oxygen is more electronegative than sulfur, now oxygen molecule can attract the several water molecules because of its polarity and make hydrogen bond with each other. I repeat, this water molecule will make hydrogen bond with another water molecule, like that. Here also, this is called hydrogen bond. I am just explaining hydrogen bond in this way. Now, what is hydrogen bond? Hydrogen bond is a weak electrostatic bond. Hydrogen bond, what is hydrogen bond? Hydrogen bond or hydrogen bonding? What is that? It is a weak electrostatic force. It is a weak electrostatic force between electronegative element with hydrogen atom which is already bonded with another electronegative atom. This is called hydrogen bond. This is dotted line, this is the parallel lines. Parallel lines are called hydrogen bond. What is that? I repeat, hydrogen bond or hydrogen bonding is a weak electrostatic bond between an electronegative element with hydrogen atom which is already bonded with another electronegative atom. And what is the mechanism behind it? Because since we know that it is electronegative element, so it carries slight negative charge. Hydrogen here less electronegative than this one, so it will attract bonding electron, it becomes slightly positive charge. As a result, this positive and negative will attract with each other to form a weak electrostatic bond which is called hydrogen bonding or hydrogen bond. So we find in case of water, this water molecule will be surrounded by the several water molecules with the help of hydrogen bonding. So water molecules different or so a large number of water molecules are associated with each other in a closed compact form, for which it becomes a liquid, because we know that liquid has a less volume than the gas. So a large number of water molecules, because of the formation of the hydrogen bonding, they are associated with each other, making a cluster, making a small volume, for which water becomes a liquid. But what happens in case of H2S, hydrogen sulfide? Here negative electronegative, this is electropositive. Here also we can consider the hydrogen bonding. Yes, here also hydrogen bonding takes place, intermolecular hydrogen bonding takes place, but since sulfur is less electronegative than oxygen, so this hydrogen bonding is not so much strong as we find in case of water. That's why in case of hydrogen sulfide, these molecules, they cannot come close with each other, or they can form an associated form like water because of the less electronegativity than oxygen, for which they are separated molecules. They are present in a jar, in a separate, in a distant, in between the distance between the two molecules. So they are not form, they do not form in associated way. So they are the gas, they are not the liquid, but water is a liquid. So let me conclude. Water becomes liquid because water molecules, they form intermolecular hydrogen bonding. What is that? A large number of water molecules are come close with each other with the help of hydrogen bonding, and they are form a cluster. They form in associated with a small volume. So we know that when large molecules, number of molecules, they are present in a small volume, they form a liquid. But when they are in a separated form, or they occupy a large volume, they are in gaseous form. And in case of hydrogen sulfide, we find that hydrogen sulfide, they do not form strong hydrogen bonding. They cannot form like water hydrogen bonding. So they are separated, and they cannot come close with each other in associated form. That's why they are gas and water is liquid. Okay, I hope you understand. The last question is, ice has more volume than water. It's also very interesting. We know that ice has more volume because if you take a glass of water and put an ice, you will see that ice is floating, which indicates that ice has less volume than water, or ice is lighter than water. Now, how will I explain that ice has more volume than water? Now, in ice, unit molecule and unit form on ice, or single unit of ice consists of 5 water molecules, in which one water molecule will be at the center of a regular tetrahedron, and the other 4 molecules are present at the 4 corners of a regular tetrahedron with the formation of intermolecular hydrogen bonding. And so 5 water molecules are very close with each other in a definite shape or definite form. That's why they occupy a large volume, where we find that 5 water molecules, when they are present in water as a liquid, they are very close compact with each other. That's why ice has more volume than water. Let me explain with the help of the structure of ice. Now, this is a central molecule of water. This is a central molecule of water. This is negative. This is a positive charge. This is a positive charge. Okay. Now, here one water molecule. One water molecule. Here also one water molecule. One water molecule. The 2 more water molecules are there. And here also one water molecule. Now the unit structure of ice, now this is the unit structure of ice, where one water molecule is at the center of the tetrahedral. If the shape is regular tetrahedral, you find there is a regular tetrahedral, and actually where the central atom is one water molecule, and there are the 4 corners of a regular tetrahedron, where the four molecules of water are present at the tetrahedral corner, and they form hydrogen bond with the central atom of oxygen or hydrogen. As a result, this tetrahedral structure consists of such a shape where the large portion is empty. Okay, this empty portion makes it lighter than water. When water is when in water, liquid water, 5 water molecules are associated, they are very close, compact with each other. That's why they occupy less volume, and this ice has more volume because of its special or specific structure like regular tetrahedral. So this tetrahedral structure, since the regular tetrahedral structure or tetrahedral structure consists of 5 water molecules where the large empty space are present. That's why it has more volume. But if you consider the water liquid, where 5 molecules of water there, they are very close, compact with each other, taking a small space. That's why they have less volume, and that's why they are more heavy than the water. Okay. Now I've discussed today these few questions. So this water that is completed today. Okay. Today is no more. Thank you very much. If you like this video, please share, subscribe, and also give the what will say like. Okay. Thank you.